Hey guys, Mr. Myas is here once again with you, and we're doing 7-6 elementary series, and we'll take on alternating series in the next video, 7-6B. What I have here are four elementary series that you are going to be required to know by memory on the AP Calculus BC exam. So this is, of course, if you're in AP Calculus BC. If you're just in Calc 2, these are four that you will definitely need to know by memory. So I recommend you start taking a look at getting some flashcards or something. But I have gone over these in the previous videos, in the previous sections. We have taken a look at some of these as power series. So sine of x is equal to this power series that I have there. Cosine of x is that one. E to the x and ln of x. So go ahead and take some time. You might want to pause this video, write those out, and then start to memorize them. Use whatever tools that you feel are necessary to do some memory things, some memory techniques. Maybe make a mind palace, something to memorize these four elementary series. All right, so let's go ahead and use these four elementary series to create new power series. All right, so really this video is how do we use those elementary series to create new power series? Well, let's go ahead and start with sine of x squared. And we've done a little bit of this before where we use substitution, or we might use a derivative or some integration or something to create our new power series using these other ones. Now, in the previous problems that we did in previous sections where I asked you to do something like this, I said, hey, use example number blah, blah, blah to come up with sine of x squared. In this case, you got to do it from memory. So use the power series sine of x to create a new power series for sine x squared. It's pretty simple. We're just going to go up here and sine x, this one right here, we're going to just plug in x squared everywhere that we see an x. And we're going to come up with our new power series, x squared minus x squared cubed. Now I'm going to show you my plugging in x squared to the fifth. If you see me looking up, it's because I have the sine x up there so I can see what I'm plugging into. X squared to the seventh over 7 factorial, and so forth. Negative 1 to the n, x squared to the 2n plus 1 over 2n plus 1 factorial. Now, if you want to, you can do x to the 6th and x to the 10th, but it's not necessary. You don't need to simplify these on the AP exam, so we're going to go and leave these alone like they are right here. Let's go and do number 2, which is the cosine of root x. So again, I'm going to go and plug it into my series above. Square root of x squared over 2 factorial plus square root of x to the 4th over 4 factorial minus square root of x to the 6th over 6 factorial, and so forth. You got to make sure that you put in this nth term. You know, you're going to want to get that credit. You got to have that nth term. All right, plus dot, dot, dot. All right, showing it's infinite. Notice here again, I didn't simplify that to x to the n. I just put square root in there. You don't have to simplify on the AP exam. They'll know that that's exactly what you're trying to do. However, if this is on a multiple choice, you're going to want to know that's going to be simplified. It may be simplified. Okay. Okay, so let's see about this one. This one's going to be multiplied. So what we're going to do is we're going to take e to the x, and we're going to multiply all the values by x. So I'm going to end up with x plus x squared plus x cubed over 2 factorial plus x to the 4th over 3 factorial, and so on. All right, there we go. All right, let's take a look at number 4 here. Now, number 4 is 1 over x. we don't really see anything going on with those other ones. We can't really do a substitution. But lucky for us, this is calculus, and we can do some calculus. Notice that 1 over x is just the derivative of ln x, right? So what we're going to do is we're going to take the derivative of the series. X minus 1 minus x minus 1 squared plus x minus 1 cubed All right, so we're going to take the derivative of the series. We're going to take the derivative of the whole thing. So the derivative of this is going to be, the derivative of this whole thing right here is going to be 1. The derivative of this is going to be 2 times x minus 1 all over 2. That's 2 and the 2. If I put this 2 down here, this 2 of the 2 is going to cancel out. So I'm going to have minus x minus 1. Plus the 3 is going to cancel out with the 3, leaving me with x minus 1 squared. If I did it again, I'd have a 4 canceling out with a 4, which would give me x minus 1 cubed. All right, so what's that going to look like as I put it all together? X minus 1 to the n. Oh, I forgot my alternating part. Negative 1 to the n minus 1 or n plus 1, either of those will work, times x minus 1 to the n minus 1. We're going to need a minus 1 here because if I'm going to start with n equals 1, then I'm going to want this to be a 0 power, which will make this all 1, which will give me that first term right there. Okay, so plus dot dot dot. All right. So that's 1 over x. Let's take a look at another one here. I'm just going to do one more. Okay, the integral of 1 to t of ln of x dx. All right, so I'm gonna take my my series, and I'm going to integrate it from 1 to t. So my series was x minus 1 minus x minus 1 squared over 2 plus x minus 1 cubed over 3 and so forth. Okay, so I'm going to integrate each of those things separately. So I'm going to get x minus 1 squared, because this whole thing is a term, over 2, minus x minus 1 cubed over, let's see, I'm going to put a 3 over this, so that's going to be 6. I'm going to leave it as 3 times 2, see what happens. Plus x minus 1 to the 4th, all over 4 times 3, minus x minus 1 to the 5th, over 5 times 4. And I'm going to evaluate that from 1 to t. So when I notice here that when I plug in a 1, it's just going to get all zeros, right? So those are just going to be all zeros. So let's only focus on the t here. So go ahead and plug the t in, and we're going to get t minus 1 squared over 2 minus t minus 1 cubed over 2 times 3 plus t minus 1 to the 4th over 3 times 4 minus. All right, so what's going on here? Well, we're definitely alternating. So let's go negative 1 to the n, n plus 1, because we want it to be an even power. So that it's an even number. And then we're going to have t minus 1 to the n plus 1, because we're going to start at 2, all over, it looks to me like we're going to do n times n plus 1. This is 1 times 2, then 2 times 3, then 3 times 4, yeah, and so forth. All right, so there we go. There's our integral. All right, so that's how we're going to use the elementary series to come up with new series, either using derivatives, integration, or substitution, or multiplication. Okay, bye. Sure.